All right, so our last lesson of the chapter is about parallel lines and the transversals, converses. And so I think the thing is, what's a converse? Converse is when you switch the if-then statements. And in this case, it's kind of cool when we switch it because it's going to be true. And so if you recall what we've learned in this chapter, the first thing, about these transversals we spoke about was, hey, guess what? You can take two lines and draw a transversal that connects between them. And it forms all sorts of different angles and they have names. And so, for example, we talked about, angle 4 and angle 2, the name we gave that was corresponding. There's other names we gave to, angles, between the two situations, but the transversal is the line that connects the two lines, it intersects them, and it forms all these angles. And so we learn the words. And the thing is, if the lines that you connect aren't parallel, they do have special words, but they're not congruent. They're not special numerically related together. And so what we learned on day 2 was the picture below where we said, hey, if you've got two parallel lines, see these two parallel lines here, and they are connected by a transversal, not only do they have special names, but also they have special numerical relationships. So angle 4 and 12 are not only corresponding, but they're congruent. And we also had alternate interior, alternate exterior. We had same side interior. We had all sorts of special things. And not only were they special names, they had special numerical relationships with them. And so the next day, we talked about how you can prove things, using those special numerical relationships. And so that was kind of cool. Now today, we're going to kind of be working it backwards. So, about the theorems, we said, if you have two parallel lines, then corresponding angles would be congruent. That was one of the theorems that we talked about. It's called the corresponding angles theorem. And now we're going to say, guess what? If you look at a drawing, okay, and the corresponding angles are congruent, guess what? The lines have got to be parallel. Okay, we're going to work it backwards. If you notice, because look at the other one, like if the lines aren't parallel, notice the corresponding angles are not congruent. That's up here with 2 and 4. So, if you have those numerical relationships, well, then the lines have to be parallel to each other. There's no other ways you could draw those lines. And so, another example would be like, okay, if you have parallel lines, okay, then that means that alternate interior angles have to be congruent. So if you have two lines joined by a transversal, the transversal, remember, that's the one that connects the two intersection points. If those are congruent, well, then guess what? The lines have to be parallel. Because look at this one, where alternate interior angles are like 2 and 6. Those are not congruent, are they? And so the only way you can draw two lines connected by a transversal and have the alternate interior angles be congruent is if those lines are parallel. So that's how we're going to be doing these proofs today. And so is by saying, let's talk about, what we know. And this is being a little bit silly. Okay. So how do you use your converses? So if you want to say, hey, guess what? I noticed this stuff, so therefore the lines have to be parallel. Well, this is how you notice the stuff. Okay, you start by stating, hey, I noticed two angles that are going to be congruent, or maybe that they're supplementary as appropriate. Remember that, I didn't mean to cross it out. Remember that angles that are congruent or supplementary as appropriate, same side interior would be ones that would be supplementary. So you start by talking about their congruence or supplementariness, and then you name them and say, hey, guess what? Those congruent angles are actually alternate interior angles. Those congruent angles are actually corresponding angles. And so you name them according to their relationship verbally, by definition of those angles. So you start by saying they're congruent or supplementary as appropriate. Then you say, hey, let's name their words. And then we say, as a result, these lines have to be parallel. Okay, because, like I said earlier, if the alternate interior angles are congruent, those lines have to be parallel. And so what is the reason? The converse, okay, the converse, walking backwards, of whatever kind of angles you name. They might be corresponding, they might be same side interior, etc. And so these are the three steps to proving that two lines are parallel. And we'll kind of practice this. It may take a couple minutes to be able to bring it together. So what are these converses? Well, normally, remember, if two lines are parallel to each other, if there's a transversal perpendicular to one of them, it's going to be perpendicular to both of them. And so that is, one of the things that we normally go the other way. Well, the converse states, if their transversal is perpendicular to both lines, well, then the lines have to be parallel to each other. There's no other way for that to happen. So if your transversal is perpendicular to two different lines, then those two lines have to be parallel to each other. And then the corresponding angles converse would be, okay, instead of saying if you've got parallel lines, then the corresponding angles are congruent. Well, if you have two corresponding angles that are congruent, guess what? Your lines have to be parallel. There's no other way for us to draw it. Next one. If you have alternate interior angles that are congruent, guess what? These lines have to be parallel. Okay, it's the converse of what we learned the other day. Next one. If you have alternate interior angles that are congruent, oh, that's exterior, sorry. Alternate exterior angles that are congruent, and I kind of cut one off, so it's down here. If you have alternate exterior angles that are congruent, well, then guess what? Your lines have to be parallel. Okay, so for them to be congruent, the lines have to be parallel. And then the converse of the same side interior would be if the sum of those two angles is 180, or if the same side interior angles are supplementary, then guess what? These lines have to be parallel. So when do you use the converse? We use converses when you're proving that lines are parallel. So you notice a numerical relationship between angles, you call out their vocabulary that unites them and their congruence, and then you say, hey, guess what? The lines have to be parallel. And so let's practice that a couple of times. Okay, so the first one would be, okay, this will be really fun. If we look at angle 1 and 6, okay, if angle 1 and 6 are congruent, can you tell that that would make some lines parallel? And the answer is absolutely. What lines? Okay, the lines would be lines L and N. The transversal that connects them is that line P. And so line L and N, okay, I should write the word L in front of it. Line L and line N are parallel to each other. Why? The converse, okay, converse of the alternate exterior. You can almost read what I said. You cannot. The converse of the alternate exterior angles. Okay, the next one, 2 and 3. Okay, so if they give you 2 and 3 being congruent, let's check it out. If 2 and 3 are congruent, does that show that there are two lines that are parallel? Well, yeah, L and M. That means that L and M would be parallel. Why? The converse of the alternate interior. Okay, if those two angles are congruent, well, then those two lines have to be parallel. So you're working backwards. Okay, what about if 5 and 6 are congruent? Does that help us figure out if things are congruent, are parallel? No, these are vertical angles. They're congruent no matter what, but that doesn't show that there's going to be parallel lines. It only has one line that is talked about there. There's two lines that are stacked, but there's not really parallel lines in question. So the answer is no to that one. Same with 4 and 5. If they tell you 4 and 5 are congruent, well, that's not really a thing. 4 and 5 would be supplementary for the lines to be parallel between M and N. So that's what they do next. So this would be no. If 4 and 5 are supplementary, and that's a different story. Okay, so for them to be supplementary, yeah, that means that line M is perpendicular to N. And why? Same side, it's the converse of same side interior. Okay, the next one they try to get all crazy, and they're like, oh, if the measure of the angle is this and 6 is this and x is 6, does that make them be parallel? Well, let's check it out. If you plug in x is 6, you're going to get the measure of angle 2 to be 50 degrees. And you're going to get the measure of angle 6 to also be 50 degrees. So let's see, if angle 2 and 6 are both 50 degrees, we should put a measure there. Okay, if their measure are both 50 degrees, let's check out 2 and 5. Ooh, those are going to be alternate interior angles. Okay, so the next one is worded a little weirdly. It says, hey, normally you would say these lines are parallel, so find the measure of x so that those angles would be congruent because they're alternate interior. But instead it says, find the measures to ensure that the lines are parallel. Okay, so the theorem we're doing is the converse, okay, of the alternate interior angles. Converse of alternate interiors. Okay, which means if the alternate interior angles are congruent, then the lines have to be parallel. Otherwise, there's no other way to draw it. And so to do that, you set the two angles equal to each other and solve it. So if you've got 5x plus 7 equals 7x minus 21, minus the 5x to go to the other side, plus the 21 to go over here, you get 28 equals 2x. X is equal to 14. And it says find the measure of angle MRQ. And if you plug this in and do 5 times 14 and add 7, you're going to get 77 degrees. And so if X is 14 in both of these, then that means both these angles would be 77 degrees. And if both those angles are 77 degrees, then therefore those lines must be parallel to each other. So we're looking to kind of work together and say, if the angles are congruent, the lines have to be parallel. So that's what we're trying to say. And then moving forward into the lesson, we're going to do a couple more questions and then do 2 proofs on the back. So let's go over here and see if we can find the back. All right, so on the back, we've got similar situations where like saying, okay, given these angle relationships, show that the lines are parallel. And so the first one says, all right, find the value of y so that the lines will be parallel to each other. And so if you look at the diagram, I spy a right angle. And so it says, one of the theorems we know is if you've got parallel lines and the transversal is a right angle with one of them, it has to be a right angle with the other one. So the opposite is true as well. The converse is true. Is if a transversal is perpendicular to both lines, well, then the lines have to be parallel. Okay, and the theorem that would be is the converse of the perpendicular transversal theorem. Okay, so which states if you have a transversal perpendicular to both lines, the lines have to be parallel to each other. There's just no other way for that to go. So how would you have to solve this so that y would cause this to be 2 parallel lines? Well, that means that these 2 angles have to be 90. And so you would set 90 equal to 4y plus 10, subtract 10, you get 80 equals 4y, divide by 4, you get y is equal to 20. So if you have y being 20, well then, first of all, the 2 angles there, the transversals can be perpendicular to both lines, and therefore the lines will be parallel to each other. And so that's a good move. Now the next one says, hey, if you've got this rowing, the question is, are these oars parallel to each other? And you're like, I don't know. They kind of look like they aren't. And the truth is they are not. So if you measure this is a straight angle here. If you find this, you would notice that this is going to be 56 degrees here. If you minus 124 from 180, you would get 56 degrees. And so these corresponding angles would not be congruent. So one of them is 56 and one of them is 50 degrees. So no, they are not parallel. Okay. And so those by virtue of those special relationships that are supposed to occur, that absolutely is not going to be a parallel set of parallel lines. Okay, over here is kind of look what it says. Okay, if angle 1 and 15 are going to be congruent, which lines would be parallel? The answer is none. Why? Because in order for them to be a special relationship, they have to be joined by a transversal, and there is no transversal that joins angle 1 and 15. Okay, so if I had told you something else, you could be like, oh yeah, there's a transversal between those 2 angles, so therefore the 2 lines that are going to be joined by that transversal would be congruent. And so let's practice with this. So if you talk about angle 3, okay, so it says, how about angle 3 and angle, let's see, what is it, 10? Okay, so I'll grab a new color. Let's grab angle 3 and angle 10. Okay, and the truth is that those are joined by a transversal here. Okay, this transversal. So the 2 lines in question that might be parallel would be this one here and this one right here. And so the transversal joins the 2 lines. And because 3 and 10 add to be 180 degrees, that means they're supplementary. That means that those 2 lines, okay, lines N and K, are parallel. Okay, why? By the converse of the same side interior angles. Okay, so you should write that all out there, but on these notes, there's not a lot of room to write. So the converse of the same side interior. Okay, the next one says, what if I give you 3 and 5 being congruent? Well, 3 and 5 are sitting right here. The transversal that connects them, okay, connects those 2 lines that could be parallel would be the lines L and M. Okay, so the transversal joins the 2 lines together. And so this is going to be the converse of the alternate interior angles, okay? And so therefore L and M would be parallel to each other. So we're kind of learning to look at a diagram and say, if the angles are numerically special together, can you tell what, if the lines will be parallel, yes or no? Okay, and so we'll do 2 proofs. Okay, first thing is angle 1 and 10 are supplementary, that's given. Okay, the next one says, if they're supplementary, the measures are going to equal what? Well, 180 degrees. How come? Well, that's a definition of supplementary. Okay, the next thing says 9 and 10 form a what? Okay, look at 9 and 10. Ooh, those form a linear pair. How come? Well, the definition of linear pair. Okay, so if the 2 lines are right next to each other and form a straight line, then that's a linear pair. Okay, So that means if they're linear pair, 9 and 10 are what to each other? Well, they're supplementary. How do you know that? Well, the linear pair theorem. Okay, and it says, okay, if angle 9 and 10 are supplementary, well then what's the measure of 9 plus the measure of 10? Well, that's 180 degrees. Why? Definition of supplementary. You can almost read that, supplementary. Okay, supplementary. And then now they're going to get a little sassy, and they're going to be like, all right, what can we do? Well, we're going to do the transitive property of equality, which means, do you see up here that 9 and 10 equal 180? And up here we say 1 and 10 equals 180. Well, if you set the two sides equal to each other, okay, and substitute in place of 180, you're going to get this one right here. It's called the transitive property, because the whole side switches out. And can you tell what happens between this step and the one below? Well, you minus the measure of angle 10 from both sides. So it's a subtraction property of equality. Okay, you're minusing the measure of angle 10 from both sides, and then you get angle 1 is equal to the measure of angle 9. Okay, and then we're going to say, hey, they're congruent. Well, that's the definition of congruent angles. Okay, and then it says, by the way, what are 9 and 10, or 1 and 9? Well, 1 and 9 are corresponding to each other. So we know they're congruent. We also know they're corresponding, by definition of corresponding. So then that means that if they're congruent and they're corresponding, well, then the lines have to be parallel, okay, by the converse of corresponding angles. Okay, so they're congruent and they're corresponding, therefore the lines have to be parallel. Otherwise, they wouldn't be corresponding and congruent. The last question is a little weird. The first couple steps are pretty awesome. It says angle 1 and 2 are congruent. That's given, okay. Angle 1 and 2 are also alternate interior by definition of alternate interior. Okay, and then you're like, what do I do next? Well, if you know two angles are congruent and they have a special relationship vocabulary-wise, then guess what? There's a theorem that says that line R is parallel to line S. Why? The converse of alternate interior. Okay, those alternate interior angles are congruent, so therefore the lines have to be parallel to each other. And then given was that our S and T are perpendicular. And the last one is going to be part of that kind of weird theorem that says, hey, guess what? If you've got two lines that are parallel in a transversal that's perpendicular to one, then it's going to be perpendicular to them both. Okay, the converse states if it's perpendicular to both, then they've got to be parallel. But this says if your transversal is perpendicular to one and the lines are parallel, it's going to be perpendicular to both. So that's what your last thing says, is the perpendicular transversal theorem. And I wrote it below there because it's a little bit different to say, hey, guess what? In a plane, if your line is perpendicular to one of them and your lines are parallel, it's going to be perpendicular to both. Okay, so I like the fact that we can say if the angles are congruent or supplementary is appropriate, we can define them, and then that means that the lines have to be parallel. And so these are going to be using the converses.